Yeah.
Oh, so, yes, all right, we are going to graph 9 graphs. Unfortunately, I'm going to save exponential and logarithmic functions, graph those until we get to that chapter on exponential and logarithmic functions, which is not all that far away, actually. So we're looking at all the good old basics, and we're going to do these in groups here. We're going to bring back, we're going to know these babies like that now. Okay, the first column, I'm going to go in columns here. The first column is everything linear. All the different graphs you know that basically result in lines. So, first, whoops, helps if I get a pen to write with. Well, first one, I'm still on lines. All right, try one more time. Okay, so the first one, we'll see if I can get an actual y. Yeah, is good old basic y equals x. Who remembers how one graphs y equals x?
It's 1.
Exactly.
What?
In terms of a t-table, because if you put 0 in for x, what will you get for y? 0, 1, 1, 2, 2. It goes to your perfect diagonal. 2, 3. Once you get it rolling, I guess for straight edges you could pull the lid off your calculator maybe. I'm going to cheat. And it goes negative too, yes. And so we get good old y equals x, our basic diagonal line. Please tell me that that rings a bell, because my heavens, how long have you been graphing those?
What is that?
What is that? So there's y equals x. But you're going, how can there be more equations that are, because I'm not going to just do more in different lines. Yes, we can change the equation and move the line around, but I'm talking about different looking things. So what were other functions you learned that pertain to lines? Well, that is, actually, that's that with simply being shifted. I'm talking about things like, anybody remember what absolute value of x looked like? V, yes, the value, V and value. Okay, but where did the coordinates pass through when you did the absolute value?
0, 0, 1, -1.
Because if you put 1 in for x, you're going to get 1 for y. If you put -1 in for x, you're going to get 1 for y. So yes, went through 0, 0, same points we just did, except it went both directions. It looks like a normal diagonal going to the right, but when you go negative, -1 also gets you +1, -2 gets you +2, etc. And so, yeah, we just get our basic diagonal. So, absolute value is always a V. Okay, the third one, if you've forgotten this one, I won't be surprised. It's probably the one we use the least, except it is good old, well actually let me ask you. We wrote it in symbols, it's written bracket X. Anybody remember its shape or its name? It's the tadpole one, yes. Yeah, oh, right, and we got the name too, hot dog. Yes, that is greatest integer. I'm impressed.
Good job, Paul.
Greatest integer. So, where did the tadpoles start? They started 0, 0. Open or closed circle?
Closed.
Yes. Yes. Closed circle. And then they went over just one unit, open circle, and hopped up. And unfortunately, they are annoyingly a bit annoying to draw. And my calibration isn't perfect, so this is hard. hope you're all going faster than I am, because I feel like this is taking forever. Okay, finally. Okay, what do you hope I do once we actually start graphing these?
You do it.
Because I'm not gonna have, I'm not,
Graphs.
you hope I shift it over so that it runs off the edges of the graph quick and you don't have to draw so many tadpoles. So do I, because that's annoying. I agree. But that's greatest integer. But once again, notice basically all the, we're still going through the dark ones, we're still going through 0, 0, 1, 1, 2, 2, 3, 3 each time. So there's greatest integer. Woo! Yeah. That was a shocker. So let's try another one. We're gonna move it up now. We're increasing our level of sophistication here. Now we're going to all things squared. So I want to graph y equals x squared. Can you see that pink or not? It's kind of hard. Kind of hard. Okay, I'll do it color then. Is that better?
Yes.
Okay. All right. X squared. Heavens, as many times as we graphed these last year, we should know this one.
Black rack? No, those are. This is brown.
I thought you just said it.
Parabolas.
Parabolas.
Oh, I did what? I said that.
Yeah, you did just say that, but then you went off in another direction. Yes, x squared, parabolas. Okay, this one you do kind of have to remember the points to plot. Okay, if I'm going to do 0, 1, 2, 3, I'm going to stick them in for there for x. So what am I going to do to them? Square. You're going to square them. So what numbers are you going to get?
0,
1, 2, 4.
And my gosh, seriously, you're not going to tell me I did 1, 4, 90 to death? At least in November, December, into January, we did a lot of parabolas. So, yes, it's your good old basic parabola, 0, 0, 1, 1 on both sides. 2, 4, and 3, 9. And y'all do know this graph paper that there's 10 squares going every direction. So instead of having to count up 9 boxes, you can just count down 1 from the top.
Oh, that would have been nice to know.
And ta-da! We have
It's amazing.
like
Amazing.
now, I can't do anything else squared, but I can do its inverse.
Square root graph.
Yes, square root.
Not good.
You
You can only
can,
do the top.
and you're right, you only do the top. What does it do to the coordinates you plot?
It turns it sideways.
It goes sideways, but what do we do to the t-table to make it go sideways?
Okay.
Yeah, inverses switch your x and y coordinates. So it's just that you're 0, 1, 2, 3. Dude, what did I get that? Okay, your 1, 2, 3, go on the right, your 1, 4, 9, go on the left. And so consequently, we're gonna go over a bunch and not up very much. So 0, 0, 1, 1, those two are always in everything. And then it's over 4, up 2, over 9, up 3. So we have our little half parabola going sideways. All right, there's our 2 squared terms. What's coming next?
The other side.
The cubes, and what shape were all things cubed?
Scrabble.
Yes, they were scrabblers. And so if we are going to graph x cubes, you're not going to be able to do very many numbers because when you start cubing things, the numbers are going to get big really fast. So on this one, you can really only graph 0, 1, 2 because anything else just goes box crazy on you. So what's going to be the right-hand side?
0, 1, 8.
0, 1, 8. There you go. So once again, 0, 0, 1, 1, and then I'm going to go up to the top and count down 2 to get to 8. And yes, it's a lucky Scrabble.
Yay.
Okay, so what's gotta be the other one I wanna do with it?
It's a sideways one.
It's a sideways one, but what would that look like? What would the actual function be? Look at x squared and square root.
Is it the third root?
Yes, it's cube root, there you go. And so yes, it's the exact same thing, you switch the 0, 1, 2 to the right hand side, you put your 0, 1, 8 on the left, and it's is indeed just gonna be your basic sideways Scrabble. 0, 0, 1, 1, 8, 2. It's all come back like that. Gonna be a snap. Boom, boom, boom. We can draw a graph. Okay. So what's next? Somebody named them a little bit ago.
Butt crack.
Butt cracks and hallways. But what kind of equation are? What do they look like? I guess.
Hallway is, ooh, it's a fraction.
Yes. There we go. Fractions. We had good old 1 over x, and we had 1 over x squared.
Yay.
Okay. What do you have to draw first before you draw these graphs? He's saying it. Okay.
The like,
Starts with an A.
I know,
Asymptotes.
Asymptotes.
There we go. We have to draw the asymptotes. Where do you always put the asymptotes? Yeah. Down the x and y axis, or when we start shifting them, wherever the new origin moves to. But yeah, we're just. So you're gonna need asymptotes for both sets. And then,
okay.
what'd you plot? You remember how many points you actually plotted for these?
None, just the first.
There's 1 point to plot on each side.
Oh, you go over, it's like how far away you are from the.
So in this case, where I have a 1 on top of the fraction, it's just gonna be over 1, 1. Because if you think about it, guys, if you put 2 in for x, y is gonna be a half. If you put 3 in for x, y is gonna be a third. So if you're, any other numbers you put in, you do fractions all the time. And let's face it, trying to plot fractions on little boxes this tiny isn't very effective. So yeah, we're pretty much gonna get 1 major point. You're gonna have 1, 1. Now the question is this the butt crack or the hallway?
Hallway.
It's the hallway. So they'll be in opposite corners. And then you're just gonna fit your curves. Now, should you draw your line straight down the grid line of the graph paper? No, get closer and closer to your asymptotes. And 1 over x squared. Obviously, it's got to be the butt crack. How do you remember it's the butt crack?
Because you have 2 butt cheeks.
Yeah, you got 2 cheeks. It's got the x squared on it. So where are they going to be? The top 2 quadrants or the bottom 2 quadrants? Top 2 quadrants. Still plotting good old 1, 1. So we're gonna plot 1, 1, and it's just gonna be 2 sideways or side by side curves.
Is this the last graph?
Yes, this is the last graph. And you have 9 lovely graphs there. And hopefully you're thinking, oh, I remember this. This isn't bad.
We're thinking, oh my gosh, what is that? Thinking it.
Thinking. Well, of course, am I going to have you just graph these
No.
and just graph these over and over and over?
No.
No, it wouldn't be any fun if we couldn't move them around, flip them over, all that good stuff. So now we have to remember all those great rules for how graphs shift around. And hopefully that's still in your brain somewhere. Okay, these rules have to also end up with the graph paper in the journal. So, or you either need to put them on a separate piece of paper or write them on the graph paper, because I want this all together as part of your journal.
Like write it down below here.
Yeah, write it down below is fine.
I put it on the backside of this.
Backside is fine.
Little tray.
I just want it to end up in there. Okay, so here we go. If I take any one of those functions, any of those 9 graphs, and I add a number on the end of it, what's it gonna do?
Go.
Do you want these on our,
Depending on.
I want them on your notes page.
this thing?
The graph paper would, yes. So like if I took a parabola and I put a +2 on it, what's it gonna do to it?
You got it right or left or up and down?
That's the question. Which way is it, up, down, left, or right?
Oh, that one's left.
I gotta vote for left. Anybody else?
No, it's down. Yeah, it's
up.
it's up.
Okay, let me give
It's
you
up.
there's a difference between when I write that or if I wrote this and I put the +2 inside the square.
That's right.
Yeah. You know that's left.
I
That's
mean,
left.
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 right,
The bottom
shoot
is
me
bottom
down,
is
guys.
left.
I don't care.
The
The other
bottom
one's
is
up.
left,
And the top one
It's
is
up.
Down.
is up.
down.
All they took is turn this figure though.
Okay, that actually kind of surprises me a little, but okay.
It's just like slope
Yeah.
slope intercept form.
Yeah, it is like slope intercept form. When we teach you slope and y-intercept, but really when we teach you slope and y-intercept, it's just the graph shifted up 2 units. You put a +2 on it. Every graph you'll ever draw, if you put a +2 on it, it goes up 2. And so of course, if I subtract, it's gotta go down. Now, that's when it's what we consider outside the function. I have x squared and then I added the 2 onto it. When we put it inside the function, in other words, this is when you replace x with a quantity. I replace the x with a whole x + 2 over here. So now, which way is it going? Left. And it goes opposite the sign. So if that's +2, it's going left 7 units. And so -c is going
Right.
right. And once you do this assignment, this will all come back and you'll just be wizards at it. Total wizards. Why am I? A little bit.
Master graphers.
Okay. What do negatives do to it?
It made it switch
X or
It's
Y.
front.
It flipped it.
It's a question of which way did it flip it? Over X or over Y?
So-
X, no, I gotta go.
Does it go upside down or does it go sideways?
Upside
down.
Upside down, yes. So, actually, I should have used the correct term, it reflects
No, don't do that.
over the x-axis. And when I put a -x on the inside,
Flips over the
Y-axis.
then it goes over the y-axis. You don't see that one all that often. There's only a few of our functions that really do that one. Because like if you take a problem with x squared, okay? If I put a -x inside a square, what happens to it?
It makes it positive.
It makes it become positive again, so it's really just x squared. Well, if you think about it, if you take a parabola and you flip it over the y-axis, if you flip it sideways, is it gonna change anything?
I mean,
No. So lots of our functions do that by putting it on the inside, the negative really doesn't have an impact. The one where you will see it have the most impact is on our good friend square root. Because if you have a negative x on the inside, instead of our half parabola going right, then our half parabola's gonna head left. That's probably the one with the biggest change, where you actually see that happen fairly frequently.
if it was x cubed, it would switch more.
X cubed, yeah, okay, x cubed is our scrabola, normally doing that. Okay, so if I put a negative x inside it, and I cube it, what will I get?
It's gonna go up on the other side.
It is gonna flip, it's gonna be over here coming down. But notice on a scrabola, flipping over the x-axis and flipping over the y get you the exact same graph. If I flip that original one upside down or I flip it sideways, it's the same graph either way.
And it makes a cool
This
sign.
tray hurts your head.
Perhaps you should sit so close with half of your desk under it. I mean, there's plenty of room. You can make Colton slide over a little and we don't want to, I don't want to have to start using my concussion knowledge. All right, last but not least, the ones you can't wait to see.
It was so much math.
Okay, here we go. If I throw a number in front, this is where it got confusing last year. I'm gonna try to unconfuse that. For example, since we're most familiar with parabolas, I'm still gonna pick on parabolas here. Okay, if our parabola is normally 0, 1, 2, 3, 1, 4, 9, what did throwing a 3 in front do to it?
Multiplies it all.
Multiplies which coordinates?
Both sides.
The y coordinates multiply by 3. So I would get 3, 12, 27. So that's the key factor. What's it make the graph do as far as looks?
It's
Remember,
gonna be,
There's only,
no, it's gonna be narrow.
because if I took, let me get a different color here. If I took and I did 3, 12, 12 would be clear up there. So I'd have 3, 3. It's gonna get narrower. It actually, we say though, it's like you grab hold of the graph, it stretches the graph. It's like you grab hold of it. I think of it as one goes up faster, but yes, it stretches it out. It's gonna rise quicker, which makes it, it's going to be a thinner graph. So the technical, they would want you to say it's a vertical stretch. If A is a number bigger than 1, it's a vertical stretch. What if that number is a half, 2/3, if it's a fraction value?
makes it vertical shrink.
That would be a vertical shrink, yes. It won't rise as fast. And it will consequently get, a parabola will get very wide then, because it won't be right going up very quickly, so it gets wide. Essentially, yeah.
Vertical shrink.
The technical name is vertical shrink. In my case, I really don't care if you can call it vertical stretch or shrink. I just want you to be able to draw the graph and know what to do with it.
Flat.
And then the one we really don't see this much. Once again, about the only place I ever deal with this is if I have a number inside a square root or a cube root. Really don't see this one very often. But this would be like saying I have square root of 3x. Now what's that do inside the function? Well, if I tell you it's exactly the opposite of the outside ones, can you guess and figure it out? If up here it was a vertical stretch,
Horizontal stretch.
Horizontal shrink.
very good. And and so forth, therefore if it's a fraction value between 0 and 1, and notice I put absolute values on there because the positive or negative doesn't matter. What would be the opposite here? A horizontal stretch, yes. And there you have it, all the transformation rules in a nutshell.
This is me in a nutshell.
I'm gonna break this.